This is part 2 of the Locket or pillbox project. If you're making an oval shape, the two ends will touch the steel block and the two longer part of the oval will have a gap and not touch and be floating. So we need to change this so all of the dome, the edges of the dome are almost or very close to touching. You can use your half-on pliers and very gently pull down on those two longer side of the oval. You're using your pliers more as leverage. You lift the two ends that are touching and you push down on the two longer sides of the oval until all of the dome touches a little bit better. You can also use your fingers and push against the ends and pull down the two sides. You can do quite a bit by twisting gently and pushing and pulling. Of course, you have to have this annealed before starting. Here we have it touching virtually everywhere, so that's good. We also want to make sure that the two domes are the same in height. And now with our side wall, if you are doing a round locket, you now need to add an angle on one side first of your wall. First, we make sure that our wall is exactly the same width everywhere. So to add this angle, and this angle is to match your dome while soldering. To add this angle, we're simply using our hand file and filing on an angle downwards. We have to guess the angle and we can check if it's matching by using our dome. So be as close as possible to it. This is for the round option. And you're going to do this all the way around. However, if you're doing the oval, that's when it's a little bit trickier. If you're doing the oval, first you need to file down the whole side wall to match your dome. So that means that you have to give that curvature on the side wall so all of the wall touch the dome and we don't have a gap on the long side. So we first will file the two tighter curve to be lower. So this is a little bit tricky for some people to get around to, so please ask if this is not making sense. So we're going to file, and this is going to take some time to match really well. So we're going to file the two tighter curve end, and then we're going to keep checking with our dome to make sure that we have a good match. This is before adding our angle that we talked about for the round shape. This is why we started with a taller wall if we're doing an oval locket. The longer the oval, the more of a dome you will need to accommodate, the more of a dome you will need to do to follow. You can look on the inside, you can see there is still a gap here, so it's not touching everywhere. So I have to keep on going and file down at the two ends. This is a very good exercise to understand how things get soldered together and shaped up to perfectly match. So as you're doing that, you're going to choose which side goes with which dome. If you change every time, you'll never get there because we're not machines. There's slight discrepancies. So you're going to pick number one with number one, and then as well, each side of the dome will match which side of the wall. So you want to always check the same thing. Every time you're checking, you want to match and check the same thing. Once things are matching well, then it's time to add the angle, just as we did with the round locket. So without changing the curvature, we will add this angle to match our dome. Add that angle all the way around. Take your time, check and double check and triple check, and ask for help if it's difficult. Take your scrubby, your green scrubby, the 3M scrubby, and remove that white coating, which is fine silver that develops when we anneal or solder. So we want to remove that inside of the dome because we're not going to file there. So we want to remove that in preparation for soldering. We don't solder on that fine white powdery surface, otherwise it would not do a good job soldering and connecting things properly. I'm using a bit of Prips flux. Now we're soldering with hard solder and it's quite high temperatures and we don't want too much fire scale or any if possible, so using Prips flux will help. Also, your Prips flux will help with the citric acid. I like Battern's flux, the yellow flux, but it's up to you, whatever you use. And of course we add a bit of flux even though we're using Prips flux. I'm using a soldering flame, not annealing, soldering, not too sharp, but definitely we want a defined blue tip. I want to heat up a bit and then you can reapply Prips flux. Prips flux is supposed to be applied, or it sticks better when it's applied after heating up a little bit. This is a perfect time where we want to deposit our solder all around before starting to solder. This is not a pick solder job, this is a chip solder job, so we're going to position our solder all the way around with our tweezer, and then we're going to heat up the object and flow the solder all at once. Heat up your object evenly. You can go slightly underneath because it's domed. Notice how I change the angle of my torch if I'm going on the other side, so it's even distribution of heat. Back, front, side to side. And I'm even a little bit later on going to go in the middle, so my object is completely evenly heated up, because we want to flow all of the solder at once. And then the sidewall would simply just sit and sink in perfectly. And we want to see that flash of solder all the way around. This tip here is for emergency situations only. If you discover a gap after that is too big to flow solder into, so an actual gap, you can put your locket or your domed piece onto a steel block, and using a planishing hammer you can very gently hit only the edges where you have the gap. You don't want to hit on the dome or you will wreck your piece. You're hitting on the edges only to bring down the dome to touch the wall. This is to be attempted with caution. It's dangerous to damage your piece. A last resort solution. And then you would go back and reflow some fresh solder to fill that gap. After, you will pickle and rinse. And then we need to shape up the other side of the wall, just as we did in the first part. So first add your curve and then add your angle along the wall. Of course, if you're doing a flat back, you don't need to do that. You need to keep things perfectly flat to accommodate your perfectly flat back wall. Using your calipers, you will check the height of the wall all the way around. I'm using the foot of the caliper, the back end, which is exactly the same measurement as this end that we use and as the top. So that tongue at the end there will give you exactly the same reading. So I'm going all the way around and I'm actually matching the parts that match. So the long side of the dome will match with the long side of the dome, and the short end, the two ends, the two tips will match together. So there's a few things to keep track of while doing this. Removing your fine silver coating. And then before soldering together, we must put a hole because this is a hollow shape. Hollow shape have to have a hole for the air to exchange in and out as you're soldering. If you do not, you will have an implosion as the piece heats up and cool. So we will take our calipers and measure halfway on our wall, opposite of our solder line. So opposite of your solder line, you will measure the wall in half, and in the middle, you can put a little mark with your caliper, and we will add a hole there. Using your about 0.6 or 0.8 millimeter ball burr, we will make an indentation where we will drill. So using your burr sideways, connecting your hands together for control, and connecting to the peg, I will add a small indentation in the metal. So always connect your hands and connect to the peg. And now switching to your drill bit, 0.6 millimeters or 0.8 millimeters, that's fine. You will drill at a low speed right in that indentation, protecting your fingers on the other side. If you notice beautiful curls of metal coming out of the hole as you're drilling, that is a good sign. That is a sign that you are drilling at the right speed and that your drill bit is still sharp. You will now position the two sides perfectly well. Please stop and double check and triple check again and again, as things may shift as you're applying flux. So take your time to make sure that your position is correct. I'm now applying my solder all the way around. You can use some flux to help your solder stick. And then we will flow all of this at the same time. For the top and bottom, obviously the solder is applied on the outside, and we are hoping that the heat of the inside of the object, which is going to get hotter and hotter, will pull that solder all the way to the inside. We wouldn't want to have solder on the inside because as we will open the locket, we want a really clean finish there. So we want to have the solder on the outside. As you see here, I'm not afraid to manipulate the object that I'm soldering. I can flip it around. Once it's attached with good flux, I can not flip it around, but rotate it and move it to accommodate what I'm doing. Still, I want to heat up everywhere. I want to heat up all around really nicely and underneath a little bit if I can, with the shape being domed. That's possible to do. And this will allow me to flow the solder all at once. After soldering, we will let it cool, pickle, and rinse. Do not quench objects with solder.